Well, hello. My name is Sia Karamalegos, and I'm going to talk to you about lightning-fast React applications. I'm very excited to talk to you. And I'm actually I like teaching adults, so I kind of hate presenting. I know that's a horrible thing to say before a presentation. So feel free to shout things at me, because I'm used to interacting with students, and I ask questions, and I'll wait for you to answer. Which is probably bad, but whatever. All right. So who am I? Can you still hear me? Oh, okay. Who am I? You can follow me on the things. I don't have all the same name. But I'm the Green Greek on Twitter and Medium, and Sia Karamalegos on GitHub. That's testing your spelling skills. And if you like not code things like art and creativity, feel free to follow me on Instagram too. I am a developer, and I live in New Orleans, Louisiana. And if you don't know, we are a bit of a party town. And this is me last year at Mardi Gras with a friend. She's a bug. I'm a peacock, but you can't see my plumage, so it's a little sad. More importantly, these are my dogs, and I have stickers of them. So if you like dogs and stickers, come find me later, and I will give you some. All right, so what are we going to talk about? We're going to talk about why you should care about performance. And in my talk, what I'm talking about is from the user perspective. So we're talking about how does it feel for a user that comes to that particular application. And so we're going to talk about why you should care, and then the things that you should always do, and then the things you should only do if your app is slow. And then those two middle things, they're actually going to be, this is a very accessible presentation if you're a beginner or intermediate, because they're just core React performance things that everyone should learn. But then we're going to take a step back out of the weeds and talk about, as a developer, what should you really care about and how to find out those performance issues. And so that part should be interesting. So why should we care? Well, according to DoubleClick by Google, 53% of mobile website visitors are abandoned, mobile site visitors are abandoned if pages take longer than 3 seconds to load. So that's terrible, right? If a user can't load the page and they just leave it, then what was the point of you developing that application? It also affects your brand and search engine optimization. So if you didn't already know, Google will put you further down in search results, especially for mobile search, if your page takes too long to load. So that's just for initial load. But what about responsiveness? So when we talk about responsiveness, we're talking about how, as a user interacts with the page, what happens. And frame rate, or frames per second, measures responsiveness. So you can see this GIF here. The top line is 50 frames per second, which is kind of close to modern browsers, or most devices right now refresh their screens at 60 frames per second. So if we convert that to an individual frame, we theoretically have 16 milliseconds to render something, but in actuality, the browser needs some of that time. So when we perform some sort of update action, we really need to target a 10 millisecond per frame, and any more than that, then the human eye can actually detect the jank, which is what this bottom row is showing. So if you're only at 12.5 frames per second, it's very visibly janky, and users don't like that. If you didn't know, you probably don't like that. So we'll keep this in mind when we dig into dev tools. So when I talk about factors that we're trying to make faster, in this presentation, we're going to talk about 3 main things, and that's initial load time. So you're talking about like your bundle size and everything else, everything that you're trying to access. Then we're going to talk about reconciliation. And reconciliation is the process or the algorithm that React uses to compare components before and after update to determine whether or not to re-render them. So that process takes some time. And then there's also the time to actually render. So what are the things that we should always do? I always feel like this is the dumbest slide, but it also happens so frequently. Has anyone seen this warning before? Anyway, you don't have to be shy. I know I have. Like in production, have you seen this warning? It seems very obvious, but one of the easiest optimizations you can do, and it comes up surprisingly often, is to use the correct build for React, or use the correct version of React in the correct build. So that means use the development version only in development and use the production version in production. The development version has different tools to help you as a developer as you're developing, and we don't need those tools in production. They're just helpful to us, and they'll slow down your application if you include them. So to give an example, I believe it was in August, a developer noticed that Slack was actually, it's a very small company, Slack, very small website that none of us use. They were doing this exact same thing. So it happens. People just ignore the warnings, and yeah. So how can we prevent it? Well, if you're using a tool like Create React App, it comes bundled in. You don't even have to worry about it anymore. When you run npm start, it automatically uses the development version, and when you run your build, it automatically uses the production version. But what if you're building something on your own, or you have your own Webpack build? Well, luckily, Webpack is smart enough to use the correct build if in the correct environment, if you add the plugin that correctly defines the node env in process.env. This is how I feel when I have to do Webpack stuff. It's like everything's going great, and I hit some sort of hurdle, but then it's all great again after I figure it out. But all right. So has anyone seen this warning? Each child in an array or iterator should have a unique key. I see this all the time because you're just coding really fast, and you're like, oh yeah, I forgot to set the key. So what does this really mean? Let's talk about what that means for a second. Well, in this, sorry, I feel like they entertain me more than they entertain the crowd. So in our scenario, our first scenario on the top, oh, now we can use this cool new feature. Is this, ooh, ooh. Everyone's supposed to say ooh. So that's no keys. We have a sloth, a lemur, and a koala in a list. And what I want to do is I want to add a turtle to the top of the list. So what's going to happen? Because if there's no key, React is going to compare each item in order, and it's going to see, oh, is turtle equal to sloth? No, it's not. Okay, I need to re-render that. Is sloth equal to lemur? No, it's not, so I need to re-render that. So it's going to re-render the entire list, and that's not very efficient, is it? So that's why we need keys, and then React knows exactly what to do. And so if we look at the good version, we have a key, and it's unique and stable. So you can see, because I have no animal repeating, so keep that in mind too. You don't want a repeating key. Sloth, lemur, and koala. And then in the bottom, I add turtle, and it sees that, okay, it can tell that turtle is a new item, but when I look at the thing with a key of sloth, I can see that I've already rendered that, so I know that I can keep that in my DOM. And so this is efficient. What you might be tempted to do is, like when a lot of us use array.map, and maybe you call index in it. So don't do this, because if you use the index, it's going to change, right? Like if you add something to the top, the item with the index of 1 is no longer equal to the item with the index of 1. This is like a really easy, dumb mistake to make, so don't be dumb. All right. What's the next thing we should do? And this is a little controversial, or I feel like almost everything isn't controversial in JavaScript these days. Like, is there not anything without opinions that go both ways? But this is such an easy thing to just do that I don't see why not to do it. But what does it mean when I say bind event handlers before we render? So let's look at what it's not, or not binding. So whenever we have an event handler, we need to access this. And so what is this when you have an event? What is this equal to? It's equal to the window. So we need to reassign this to the scope that we want. And so the way that we do that is we bind them. And you can do this with the arrow function, which you can see right here. But because I'm doing it in render, every time I have an update, it's going to create a new function, and it's going to see that as a prop change and re-render. So how do we prevent that? we can bind before render. And that's why if you've ever seen people when they define their functions inside their classes or their components, they do the arrow function up here. This is the easiest way to do it. There's actually multiple ways to do it. It's just my preferred way, so that's what I'm showing you. And then you just call that. And so when the instance of the class is created, this is bound to the class or to the instance, and it's not recreated every time we need to render. So another item is don't mutate objects. So what do we mean by that? Immutable means unchanging. So in case anyone's really beginner, I want to take a step back and explain that. So once it's created, it cannot be changed. Determining whether a proper an item and state has changed is way easier if you don't mutate the data. For example, if you push and pop things into an array, it mutates that array. And so React and Redux have performance optimizations that do shallow checking on your arrays and objects and so that they can render things faster. But if you're mutating, it's not going to detect that. And so what we do is we create new objects every time we update things so that it's easier to shallow check. And you can do that with the spread operator. That's one of my favorites, object.assign. Map and filter are things that you can use, but don't use push and pop. And then you can also use libraries like immutable.js. So which things should we do only if dev tools show performance issues? So we're still in the core React part. We're still just in the forest. Or what is it, the trees? We're just looking at the trees, but not the forest. So sometimes we don't need React to go through that whole process of reconciliation because we know the cases when a component shouldn't re-render. So we can basically just hijack reconciliation. So the lifecycle method should component update will override the reconciliation process before it starts. So if you have a custom function that you want to check, you can do it there. By default, it returns true. But if you define it, you can return false if you don't want it to update. I'm like on time. What time did I start? I don't want to go too far over. But anyways, so this is a simple button, and it has a color, and there's a counter and state. And so in this example, I'm checking if both the prop of color and the state of the counter have changed. And if they have not, then I return false so that it skips reconciliation. In most cases, we're checking all props and state, so there's actually an easier way to do this. So this is the exact same example, but instead I'm just inheriting from pure component instead of component. For both of these, you do need to be careful because it will affect your child components, and it won't trigger updates for those as well. So definitely be careful how you use these things, and don't bother with them until you actually have an issue. Of course, that's my opinion, talking about opinions in JavaScript. If you use Redux, it's great at shallow comparing to reduce unnecessary re-renders, but it has a catch. Whenever we use that connect function, if we compute values in map state to props or map dispatch to props, a new object is returned every time, resulting in a re-render of the tree. So what does that mean? In this example, it's like your typical to-do application. I want to map state to props, and I want to pass a prop of things, but I want it to be based on a filter. So like show all, or show open, or show closed. And so I have a function that takes that filter and gives me the correct items. But because I'm computing that, Redux is not going to recognize when those things haven't changed. So luckily, there is a cool package called Reselect that will help you out with that. And it gives you a create selector function, and it memoizes or caches the results of our function. So every time we pass it the same inputs, it will just return the cache version of the results rather than recalculating everything. So we're back to where we need to be. So one more item you can do if you ever have an enormous list of items. There's no reason to render them all. You can use windowing to only render the subset of the items at a time, cutting down on both render and re-render time. So React Virtualize is one tool you can use, and you can research more. Oh, I did forget to mention at the beginning of this presentation, you don't have to copy a bunch of the things down, like the code or the links. I'm providing all the links and the slides at the end of the presentation. And I'll tweet them out later, too. So big picture. What really matters? We learned some of the basics of these core React speed best practices, but we've been deep in the weeds. Let's take a step back and think about how we can strategically improve performance for our daily jobs in web development. So how many of you have heard of the 80-20 rule? Yay. So the 80-20 rule, or the Pareto principle, says that roughly 80% of the effects come from 20% of the causes. And this is not like super scientific. It's just we found that it's true in a lot of circumstances. And so this gets back to a little bit of using your time wisely and just shipping code. How do we not dive so deeply into a rabbit hole of performance optimization that we don't get anything done? So how should we manage our time? Well, we should not optimize what we don't need to. So be lazy. I used to joke with all my employers that I deliver a lot. Like I'm one of those people that executes a lot. But when people ask me what inspires me, I'm like, I want to be lazy. I want to make it so that my job doesn't need to exist. So I always find ways to do things better or faster. But of course, they always invent new things for you to do anyways. But so what's the first step? We actually need to find those causes. So how do we find those causes to optimize? And I want you guys to be honest here. How does this make you feel? Does it make you a little bit nervous? I'm trying to judge. Because this gets back to also not everyone knows everything, and a lot of us aren't really that great at all these things. So does it make you feel nervous or a little bit scared? This is my dog. He's like, don't take my fuzzy pillow away from me. That's actually a pillow behind him. It looks exactly like him. He thinks it's his cousin or something. And he's like, please don't take it. So he's like scared and sad at the same time. So if thinking about dev tools makes you scared and sad, then maybe it's time you should learn it better already. If you want to make your life easier, you really should learn how to measure what's really going on with your app so you don't waste a lot of your time optimizing things that don't matter. There's a really excellent resource. It's at the bottom of the slide, but don't copy that because I'm going to give it to you at the end. It's even specifically for React, so I'm going to give you lots of great tools for learning these things. But basically, in development mode, you can visualize how components mount, update, and amount using performance tools. And most of the modern browsers have these dev tools. Specifically in Chrome, you can go to the Performance tab. And if you look under the user timing label, that's where all the React events will be. So you can see unnecessary components that are unnecessarily rendering that you don't need and whatnot. One thing to note, though, is that the numbers are relative because you're probably going to do this in dev mode. And so don't necessarily get hung up on the actual amount of time. You just want to look at relatively, do I have wasted renders that I don't need? Because in production, it will run faster with the production build. I had to change my presentation format software because it was running GIF slowly, and now nothing's working right. All right, the other thing you can do is you can use React Dev Tools. So this is a screenshot of Chrome. And if you have installed the React Dev Tools and you click on Highlight Updates, you can actually visualize the updates. It will briefly add a colored border to the components that have updated. So you can kind of visualize what's going on as well if you don't like graphs as much. So taking a step out of just React, I'm guessing most of us use Webpack as our bundler these days, and Analyzing our build statistics is a good step towards understanding Webpack better. And visualizing your build helps you understand the composition of your bundles. And from here, you can see whether you should implement things like tree shaking, code splitting, dynamic imports, and other stuff. And I'm not going to explain what all of those things are, but because you can learn them in several other tutorials. But this is just screenshots from several tools that help you visualize what's going on with your Webpack build. I really like this one. I'm a big fan of data and charts, and you can see that, Lodash is huge in here. So you can also learn how to do dynamic imports of only what you need. So yes, learn Webpack better. Yuho, who I think everyone loved his lightning talk yesterday about the future of development. He has an excellent website called Survive.js, which teaches you about Webpack, and a good article about how to analyze your Webpack bundles. So, can anyone answer this? What accounts for 60% of the bytes on average needed to load a page? I got this from a Google training, so I don't actually have a quote on the web. That's why it just says Google and nothing else. You just have to believe me. Anyone? What? Phones? No. What? No, I didn't hear you. Shout louder. Phones. Fonts. Oh, that's funny. I was guessing someone was going to shout pornography, which might be true, but that's not where I'm going. At least you didn't say that. But it's images. So it's like this thing that most of us probably don't even think about anymore. When was the last time you thought about the images that you're using in your app, like either static ones or ones that you're importing from your database? Some of us do. If you're already thinking about this, you probably don't need to be in this room for my talk. But how many of us have actually done this? So lately I've been working on a static website, which I haven't done in a while, and it's taught me to appreciate. I have to use just HTML, CSS, and vanilla JavaScript for reasons of the client, which has been frustrating. But it's also taught me a lot about going back to basics can really improve performance, because I'm using a lot of the audit tools. Also, Google DevTools has an audit tab, which you can really dive in. It'll tell you exactly things that you could optimize on your website. But in terms of images, since they are so much, and of course it's going to vary by application, but understand the difference between image types and use the appropriate format for your use case, like PNGs and JPEGs and SVGs. And I have a lot of great links for resources on how to learn these things. There are even some amazing packages that you can use with Webpack that will automate both image optimization. So if you serve the wrong or the image at a much larger size than you really need to, you can optimize that. But you can also provide source sets and load the correct image for the correct screen size, and that helps improve. For example, if you're on a mobile phone, your network might not be as good, or you have a lot of clients that just don't have as good coverage. And so you want to make sure you're not loading really large images for really small screen sizes. And I know it sounds, we're going back to basics here, but if it's 60% of what's on the web, I feel like it deserves a little bit of our attention, even though JavaScript is fun. All right, so if you need more speed, check out tree shaking, code splitting. You probably heard all these terms. Some of you already know these concepts. Server-side rendering, progressive enhancement. And then a lot of the people that have presented here, a lot of the speakers have written and talked about a lot of the tools that you can use. I like Next.js a lot for doing server-side rendering and code splitting. It's a really easy tool to use. Yeah. So that's the core of my talk. Don't read this slide. This is there for later if you look at the slides. But I'm giving you a lot of different tools here to learn more, or targeted tools to learn more, that have actually, at least I've already read and think they're good enough to share. Some of them still mention the perf package. So React before version 16, I think, had this perf package that you could add on, and it would tell you about your wasted renders and stuff like that. But you can ignore those parts and just read the rest of it because the other tips are still good. There's a free course on Udacity about responsive images, and it's a bit basic at first, but it uses gulp, which is just like, but it still covers the core concepts, and you can go right through that really fast. So thanks a lot. That's where you can find the slides and resources. You have to be able to spell my name. I know, I apologize, it's very Greek. And if you want to give me feedback, there's a link for you to give me feedback, because I like teaching and I know about presenting. But thanks a lot.